Hello friends, here Dr. BC, and today in this video episode I am going to show you the adaptive fast charging of lithium-ion batteries. Modern gadgets require energy, and especially if you are traveling with your gadget need battery. Nowadays, lithium-ion chemistry batteries are on its rapid phase. These batteries are very compact and has high power density. Now, instead of that, you can see there are various lithium-ion batteries. It can come in a compact this size, or you can find these lithium-ion batteries in a 18650 cell like that. And moreover, you can consult that this type of batteries are in your smartphone, and you can see that I have a Spice, that is an old generation smartphone which is around 3 or 4 years old. You can see that again it has a lithium ion batteries, and it is a compact size. Here you can see a gadget that is a Wi-Fi dongle, that is 3G 4G, and again it is a compact size lithium ion batteries. And if you see this Intex phone, it comes again with the same lithium ion batteries. A watch, again the same lithium ion batteries. Even you can see the charging bank, that is power bank from Xiaomi. It again contains this 18650 cells. Now if you see the power bank like that, it again contains this 18650 batteries. Now the question arises in the mind, how to charge these batteries. Now you can see that in market there are various type of chargers available which can charge this 18650 cells, like this power bank and this power bank. It can charge this 18650 batteries inside that. It is specially designed for to charge this battery. Right now it is the capacity of this battery varies from 100 milliampere hour to around 3200 milliampere hour. Now in this power bank you can find a 2600 milliampere hour batteries which can be charged easily through this micro USB port. Okay, same with micro USB port. If you see the battery port on this Intex mobile, again micro USB port. On the same you can find this micro USB port. So whole of this thing can be charged with 5-volt adapter. That is like that is a fast charging adapter from the Samsung, or you can charge with a commonly available 5-volt charger. All of this charger can charge all of this stuff, but with different rate. Why I am saying that with different rate? Because these chargers have the different capacities. Now if you see the capacity on this Samsung charger, you can see that the capacity of this charges is the output is at 5 volt at 0.7, that is 735, that is of a 3.5 watt charger. And if you see the total capacity of this battery, that is 10,400 milliampere with 3.6, and that goes around 37 watts. That means this charger will charge this power bank in roughly 10 hours. Okay, now if you see the battery on this Intex mobile, let's try to open that. It is Qualcomm battery, and it is rated at 1400 milliampere hour. That's mean 5.18 watt hour. That means this charger can charge this battery within 1 to 2 hours, more than 1 and less than 2 hours. That means it is fine. That is fully okay. Now if you move towards the recent smartphone available in the market, like this Note 5, it has a 3000 milliampere hour battery inside. Now if we calculate the charging time, that is 300 into 4 to 12, that means 12 how much? Okay, and I will show you that one. It has a 3000 milliampere hour battery inside, and the voltage of that battery is around 3.6. that is means it has a 10 watt. That means this charger will roughly charge this battery in around 3 hours, more than 3 hours. That is the total time that is required to charge this battery with the help of this charger. So that you can see that it is taking a very large time to charge this battery. Who wants to take this time, that is around 3 hours to charge this battery, that is very big time. Now if you see the current technology, you can see that currently Qualcomm has introduced a quick charge technology, that is a quick charge 2.0 in the market. And what is that quick adaptive fast charging? That is a quick charging 2.0. Now in this video episode I am going to show you the adaptive fast charging of a battery. Now before that I will just put all of this thing aside. Now every battery has some capacity. Let's suppose I have a battery which has a capacity of 2600 milliampere hour, and the output voltage that is roughly at 3.6 volt, that is a standardized voltage. And let's suppose the specification of this battery, that is tell me by the manufacturer that it can charge up to 1C. What is 1C? That it can be charged maximum up to 2600 milliampere only. You cannot go beyond that. It will break the chemistry inside the battery, and you know that this lithium metal can be very dangerous. When it is come in contact with air, it start burning, and in a battery this lithium foils are compressed very tightly, and once it contact when it burst and the lithium get in contact with air, it explode like that. So to minimize that problem, the manufacturer of the battery always rate the charging capacity, that is charging capacity of that battery, that you can charge this battery up to 1C, 2C or 0.2C to 1 or 2C. Okay, that is the charging capacity of the battery. Now let's suppose that 2600 milliampere hour battery has a 1C charging rate. Now how this battery is charged? Through this 1C current. Now every battery, lithium-ion battery, can be charged in 2 steps. That is, one is called as constant current and another is called as constant voltage. Initially what you can see that the charger output, charger output to the battery, that's mean you have there the charger and you have connected a battery to that charger, plus and negative, and the charger output is at constant current. The constant current maximum up to 1C. So let's suppose 1C 2600 milliampere and the charger current is constant and the battery is connected to that constant current. Now let's suppose the initial voltage on the battery is around 2.85, that is cutoff voltage of the battery, and as the time rises, just on this axis there is time and there exists the time, here is the current and here is the voltage. As the time increases, the voltage start increasing. Now once the voltage reaches up to 4.2 volt, let's suppose at that time that voltage reaches to 1.4 volt, that is around 60 minutes. Now that is a 60 minutes here. Now the current start, the power adapter or the charging circuit or charging module inside the mobile phone switches to constant voltage mode, and then constant voltage mode method, that's the terminal output at the charger output to the battery terminal is at constant voltage, that is 4.2 volt. Now the terminal voltage of the battery is at the 4.2 volt and the current start decaying. It decay like that. Now this 60 minutes time, when the terminal voltage of the battery rises from 2.85 to 4.2 volt, says that it is now 85% charged. Remaining 15% charging is done at constant voltage, and you can imagine that it will take certain time, and once it reaches up to 20% of this value, that is 20% of this value, thus we can say that the battery is fully charged, and then the current charging circuit stop sending the current to the battery, and we can say that the battery is now fully charged. And that is the point where the voltage drops certainly to 4.11 volt from 4.2 volt. Now the charging is stopped. So this is a traditional method for inputting or for the charging a battery. Now all of these chargers do the same. Now let's see a charger. Now let's suppose I have this old generation Samsung charger, this one. It is rated at output at 5 volt and ampere rating is around 0.7 ampere, that is 7 5 the 35, 3.5 watt. That means it can input only 3.5 watt inside your battery in constant current mode. That maximum current you can supply to the battery, it can only supply up to 3.5 watt. Now the Qualcomm 1.0 technology, quick charge 1.0 technology, in that the Qualcomm has done a very good research in quick charge 1.0 technology. Qualcomm has increased the capacity of a charger, that is a capacity of a charger from this 5 volt 0.7 or 1 ampere to 5 volt 2 ampere. Now the charger has an output of 5 volt at 2 ampere. That means it can deliver up to 10 watt to the battery. Now as you all know that all of these phones have the different batteries capacities. Even the charging bank, which also support this USB 5.0 charging, all has the different battery inside. Because of the different capacity of the battery inside, all of this equipment or devices taking time accordingly. This will take 2 or 3 hours, 2-3 hours. This will take 10 hours. Note 5, the Note 5 will take more than 4 hours or 3 hours to charge with this adapter. Now if you want to charge this fastly, you have to switch the charger from this 0.7 ampere to a 2 ampere charger, like that charger, and this will definitely charge the battery as fast. Now let's calculate that one also. That is a 300 milliampere hour battery, and it is rated at 3.6, 3 to the 9, and roughly I can say that it is of 10,000 watt hour battery, that is inside this Note 5, and with a 3 watt charger it will take 3. You can imagine that. Okay, that is 10, that is 3 to the 9, that is 3 to the 9, 3 hours times for charging up to 85% of the total capacity of the battery, and remaining 15%, which is done at constant voltage mode. Again we can see that in certain scenario, if you see the graph, it is like that. It is like that, constant voltage, constant current, and then constant voltage. And if you see the timing on this x-axis, so both of this timing are quite similar. This if this take 1 hour, and this again takes 1 hour. Means if it takes this 3 hours to go to this level, and again definitely 2 to 3 hours in constant voltage mode also. So this will definitely takes a higher time to charge this battery with the help of this adapter. Now if you charge this battery with a 2 ampere charger, 5 volt, okay, 5 volt and 2 ampere, that means you are putting a 10 watt to this battery at constant current mode, then you can see that again that is 10 watt hour and 10, that means it will take 1 hour to reach this 85% benchmark approximately with the help of this charger, and 1 hour again, and approximately within 2 to 3 hours the battery will full with the help of this charger. Now that is a Qualcomm 1.0 technology to charge this lithium-ion battery. Now the next technology, that is Qualcomm quick charge 2.0. Now Qualcomm quick charge 2.0 technology, that means you can see a second output on this charger, that is 9 volt at 1.67 ampere. If you go through that, that is 9 volt at 1.67 ampere, it roughly goes to 15 watt. That means instead of putting a 10 watt, you are putting a 15 watt inside a battery in constant current mode. That means your battery is now fastly charged. If you calculate the charging time, that is 10 by 15, that is 6.66, that is around 36 or 40 minutes. That means you can reach up to 85 benchmark on this with the help of this charger within 40 minutes instead of 1 hour. So you can see that you have reduces the time of quick charging of the battery. So by the help of this new chargers that is rated at 9 volt and 1.67 ampere, and the same one is here, and this one that is at output at 20 volt, that is 19.5 volt at 1.2 ampere, that is roughly around 24 watt is sent to the battery at the same time. Now how this charger will charge your battery so fast? It again goes in the constant current mode, where you can charge the battery with 1C. Let's suppose all of these batteries that I have in the market, that is inside your smartphone, has the charging limit up to 1C. Let's suppose you can see that the maximum charging in Qualcomm quick charge 1.0, maximum current is 2 ampere. Now if there is a battery inside your phone that is of 3000 milliampere hour, that means you can charge it with a 3 ampere current also, but your charger is limited up to 2 ampere. So you can see that the battery charging at lower charging current at the initial stage of constant current mode. So by the help of this Qualcomm quick charge 2.0 technology, where you can put a maximum wattage and then the maximum current to the battery at the same time. So you can see that a quick charge 2.0 technology can charge your battery faster as compared to quick charge 1.0 or a traditional charging technique. Now what's happened inside your phone and the charger when you are connect that is adaptive fast charger, with your smartphone. Now your smartphone has a power management chip. This power management chip send a data signal at D plus and D negative line to the charging IC, that is charging IC that is inside this Qualcomm adaptive charging module. And if this phone where this power management IC is placed support this fast charging, it asks the charger to step on the voltage, that is step on the voltage from 5 volt to 9 volt. Again it is depend upon the combination of this D plus and D negative line. If both of the lines are shorted, then it is asked for the power at 5 volt. If one of the line is up and down, it will ask the IC that is inside this charger to switch to a 9 volt. So you can see that by the help of this charging IC inside the adapter and the power management IC inside the phone, you can switch from 5 volt to 9 volt. Now let's see a adaptive fast charger, what is inside that. I had already take this apart. Now if you see that charger, and you can see that here is this SMPS portion, the mains goes here and it rectified and then it is first filter out and then rectified and then again filter out with the help of the capacitor and then put to this switching transistor, that is here, and the oscillator is inside that, and then on the secondary winding of this transformer you get a 5 volt, and that is now rectified and give to this terminal of the USB. Now here is a quick charge IC, that is on the charger side, and this charger IC detect the D plus and D negative lines, and if this D plus and D negative lines are different than 0, then this quick charging IC is turn on and it will send a signal to the oscillator through this optocoupler, and it will increase the pulse width modulation frequency of this transistor, and the output voltage is now jump from 5 volt to 9 volt, and such that charging will go on. Now if you put another device which doesn't support this Qualcomm quick charge at that point, that doesn't give this D plus and D negative line at different voltage input reference, and the Qualcomm that is quick charging IC turned off, and it doesn't provide feedback through this optocoupler to this oscillator, and the power remains on the 5 volt. So by the help of this method, that is you can charge your phone smartly and efficiently with more wattage and you can charge this phone, that is a Samsung Galaxy Note 5 within 40 minutes up to 85% charging level with the help of this adaptive fast charging circuit. Now Qualcomm is introducing a quick charge 3.0. Now what is 3.0? Before that I will show you class A and class B charging, adaptive quick charging 2.0. The class A support output at 5 volt, 9 volt and 12 volt, and class B output at 5 volt, 9 volt, 12 volt and 20 volt. This is a Qualcomm quick charging technology, that is 2.0. Okay, that is Qualcomm quick charging technology at 2.0. Okay, now this 5 volt, that is at 10 watt, 9 volt at 15 watt, and that is 20 watt, and that is 24 or 25 watt. Okay, depending upon the power pack that you have inside your smartphone, mobile phone or laptop, this class are used. That is either it charge at 5 volt or 9 volt, either it can charge at 5 volt or 12 volt, either it can charge at 5 volt or 20 volt. That depend upon the class A or class B. It has only 2 mode of operation. Now in quick charge 3.0 technology, in 3.0 technology what happens, now instead of smartphone, which I am saying that phone is smart, now the charger gets smart in this technology. Now what is the charger gets smart? That means now the charger has a smart microcontroller inside it, which will see the output from the power management IC from the smartphone, and that is a charging microcontroller. And depending upon the power input, power on the battery and the material from which the battery is made, depending upon that, this microcontroller decided how much power is given to that battery. Now what is advantage of this technology? This technology clearly fast charge your phone, and also it is very efficient. Now why it is efficient more than this 2.0? Because 2.0 basically depend upon only 2 voltages, 2 wattages, 5 or 9 volt like in the Samsung and so on another devices. Now this will switch from different mode, 5, 9, 12, 20, depending upon if the charge battery is at 85%, it will switch on the 5 volt. If battery is at 0%, then it will switch to 20 volt, and then when it reaches up to 10 or 20% charge, it will switch to 12 volt and so on. And by the help of this charging switching technique, you can charge the battery very quickly, and it is more efficiently than this 2.0 technology. So in Qualcomm quick charge 3.0 technology, instead of the phone get smarter, the charger will also get smarter. That is Qualcomm quick charge 3.0 technology. So I think you will understand how this adaptive fast charging work. Now this completed this part of the video. If you like this video, give a thumbs up, share and subscribe. The subscription link is shown on your screen, and for more videos on upcoming gadgets, technology and many more, keep watching BCD Tech. Thank you and have a nice day.